Hey everyone, let's do some interval of and radius of convergence finding using, as always, the ratio test. Right? Remember that this is the same as it used to be in section 11.6, except now we've got a variable x that could assume multiple values. So we have to figure out all the values of x that could allow for the series to converge, and that'll be the interval of convergence. Then we just take half the length of that interval, and that's the radius of convergence. So we have the limit as n approaches infinity, and as I mentioned in class, now more than ever, it's very important to include the absolute value when you're doing this, because otherwise you might only be getting half the values of x. So we do this, right? We're finding the n plus first term, and then we're dividing by the nth term. Right, and I guess this will give us, right, we can group our stuff accordingly. I know in class we like to just cross stuff out, but this is a video, so I'll take that extra minute, write it all out, and then do some cancellation. Okay. So when we cross stuff out, right, that cancels, that cancels, that cancels, right? And we're left with a limit of, it looks like, the absolute value of 2x minus 1 over 5. And we want this to be less than 1. So we want this to be less than 1. When is this true? Well, it's true when negative 1 is less than 2x minus 1 over 5, which is less than 1, right? You see what I did there? I just sort of reflected the 1 to the other side, made it negative, and got rid of the absolute value signs. And then this, of course, implies negative 5 is less than 2x minus 1, which is less than 5, right? You see how we just multiplied by 5? And then we're going to add 1 divided by 2, right? That'll give us negative 4, so I think it's negative 2. Right, we add 1, we get negative 4 divided, okay. X, right, we're going to add 1, we get 6. Right, so x is between negative 2 and 3. You can say this, so because we know this, we know, so we can actually tell the radius of convergence at this point. The radius of convergence is going to equal 3 minus negative 2 divided by 2, which is 5/2. Right, because a single point here or there won't change the length of the interval or the radius of convergence. Okay? So now what we need to do is we need to consider the special cases, right? What happens when x equals negative 2 and what happens when x equals 3? And it really is best to rewrite the series with x equaling, in this case, what, negative 2. So it looks like we have negative 5 to the n over 5 to the n. I'm going to go ahead and simplify that just because... wait, we're starting at 1, sorry. Well, no, I won't simplify it right off the bat. I'll show you, right? We're going to have, right, negative 5 to the n over 5 to the n root n. And we see that that's going to equal negative 1 to the n over root n. And we should know that this is going to converge by the alternating series test, but of course we still have to show it. So maybe not the best writing here, but right, the limit as n approaches infinity of 1 over n, root n equals 0. And 1 over root n plus 1 is clearly less than 1 over root n. I'll put this in parentheses. Converges by the alternating series test. Okay. So we know that x equals -2 is going to be in our interval of convergence. Okay, next up. Maybe I'll do one of these guys just to sort of separate it and keep doing one of these guys, right? Now we're going to let, x equal 3. So what do we have this time? Sum from 1 to infinity of, looks like 5 to the n. Is that what we have? Yeah, right? Yeah, 6 minus 1 to the n. 5 to the n over 5 to the n root n. And we can see a pretty nice cancellation going on right there. Well, maybe I'll just rewrite it. 1 over root n, right? This time there's no alternating term. And we should see that this is a divergent p-series. Right, because p equals 1/2, which is less than or equal to 1. Okay? So just to answer the question, so the original series has interval of convergence, I guess you could say it's -2 with a bracket to 3 with a parenthesis. Or you could write it as -2 is less than or equal to x, which is less than 3. And radius, I'll denote it with r, equals 5/2. Okay? So that's the answer. So that's how you do this type of problem.